Hi students, I'm going to do the best that I can to give you guys a lesson here today since I'm not feeling well and I'm going to go home. So you have your Unit 4 packet that you should have picked up, piecewise linear and absolute value functions. We're going to talk about piecewise linear functions here. Our first topic is evaluating piecewise functions, so talking about the evaluation part of them. So functions expressed algebraically can sometimes be more complicated and involve different equations for different portions of their domains. These are known as piecewise functions as they come in pieces. So we've seen a few examples of these diagrams before, but this is where we're actually going to get into talking about them. So you can see the first idea here is that there are different pieces to this function. You can't just write one line to represent it, but it gives us those different pieces, and different piecewise functions look different as they go. So you have a warm-up question here. I want you to try this out, see if you can answer these questions. Whoever's in the room hopefully will pause this video right now, give them a little bit to try these questions, and then hit play. Okay, now that we are back here, the relationship between the postage rate and the weight of a letter can be defined by a piecewise function. The graph below shows the 2018 postage rates for using regular service to mail a letter. So what I'm seeing down here is the weight in ounces, so the weight of the letter, and then over here is the postage in dollars, so the amount that it costs. What is the price of a letter that has the following weight? So 1 ounce. So if I come down here and find 1 ounce and I come up to the function, remember a closed circle represents where it exists and an open circle means it doesn't hit that. So this is where we're at here. That postage rate is 0.5, which can be written two ways as 0.50 with a dollar sign in the front, or you can write it as 50 cents with the cent sign in the back. So that's your first one. Your second one, 1.1 ounces. So if I go just beyond 1 ounce and I come up here, my function, I'm not going to hit it until I get to that line. Now, we're not exact here. I'm going to say that's at about 0.7. I might be a little bit off, but I'm going to go with 0.70. Again, put the dollar sign in the front, or I can say 70 cents and put that cent sign in the back there. And the last one is 0.9 ounces. So working around that 1 ounce there, if I come back to 0.9, I actually get to the function down here at the same level as it was at 1. And so it does cost me the same amount, which is 50 cents, which can be written two different ways. Okay. A letter costs 92 cents to mail. How much does the letter weigh? So if I come up here and find 92 cents, it's going to be somewhere below this one. So it's got to be this piece over here. And weight of that is actually going to have to be an interval. So we're going to have to say somewhere between 2 and 3, and it's inclusive of 3. So that's the one that's filled in there. So I can write that as an open bracket with a 2, 3, and then a closed bracket or the square bracket there. Or I can say that 2 is less than W, which is less than or equal to 3. So either one of those methods. You can also write that out and say between 2 and 3, inclusive of 3. Or both ways you can do that one. Okay, so that's our warm-up number 1. If we flip the page and go to our warm-up number 2, again, whoever is controlling this video, if you can hit pause for a little bit, give everybody a chance to try this one out. Okay, so if we've tried this one out then, warm up 2 here, a self-serve frozen yogurt store sells servings up to 12 ounces. It charges 50 cents per ounce for a serving between 0 and 8 ounces. So I'm thinking there that we're going up between 0 and 8 ounces. We're going up by a certain amount per ounce, and $4 for any serving greater than 8 ounces and up to 12 ounces. So between 8 and 12, we're going to kind of flatline there. So the only graph that does that is graph B here. In graph A, this would be as if it was charging us 50 cents per ounce all the way to 12 ounces. This one would be as if, letter C would be as if it charged us $4 no matter how many ounces we had. So even if we had 1 ounce, charged us $4. And then letter D down here is actually charging us less than 50 cents an ounce, and it is just working up to where it'd be $4 at 12 ounces. So that one is not correct either. So then let P of Y be the function that gives the price in dollars of a frozen yogurt weighing Y ounces. So explain P of 4 equal to 2 in the context of this scenario. So remember, we've talked about the fact that f of x is equal to y. And so in this case, that 4 kind of represents that x and that 2 represents that y. Now, a little bit confusing here because y is the number of ounces. So they're telling us that y is this axis down here, but that's just how we have to read that. So 4 is going to give me that axis. And if I'm looking at this, that's the 4 that's here. And if I go up on the chart, that's where I end up to, and I end up with 2 for the price in dollars. So what it is telling me is that if I have 4 ounces of yogurt, that is $2. Okay. And then last but not least, just some function notation here, understanding these. So P of what is equal to 1. Again, I go back to that idea that f of x is equal to y. So we know that this 1 is a y value or on the y-axis. So if I find where 1 is on the y-axis here and come over, I find the line, and then I come down, I get to 2. So P of 2 is equal to 1. And if we're asking P of 12 is equal to what, that's an x value. Or again, the x-axis there. So I'm going to, on x value, I'm going to find 12. I'm going to come up and find the graph, and that ends up at $4. So I'm going to fill in P of 12 is equal to 4. Okay. Now, our examples here for piecewise is just evaluating them, is understanding them. We have an f of t function over here, and then we have an f of a function over here. So we're going to use this f of t function over here for all of question 1. So it says f of 8. Now, if we read this piecewise function, there's 3 different pieces to it, and each one has its own condition. So what you actually have to do is look at the condition first. So if 8, which is my t value, look at where t is here. This is my t value of 8. I have to go find which condition I'm looking at. So when 8 is the case, t is equal to 8, I'm using this function here. So I'm going to do negative 64 divided by t. In this case, my t is 8, which is negative 64 divided by 8 is negative 8. So my f of 8 is equal to negative 8 there. You do your next one. So your next one, f of 1, again, you're going to look for that t value first. So if I come over here, it's not 8. 1 is not 10. So 1 is just where t is not 8 or 10. And so this is where I'm going to look here. And so I'm going to come back to this and I'm going to plug it in. So I put t value in. So it's going to be the quantity of 1 squared minus 3 times 1 plus 2. If I do my order of operations, 1 squared is 1, minus 3 times 1 is 3, plus 2. 1 minus 3 is negative 2, plus 2 is going to give me 0. So my f of 1 is going to give me 0. My next one there, f of 0. So again, t is equal to 8. Nope, 0 is not 8. 0 is not 10. So we're going to use this bottom one again. Plug it in. So I'm going to do 0 squared minus 3 times 0 plus 2. So 0 squared is 0, minus 3 times 0 is 0, plus 2 is going to leave me with an answer of 2. So f of 0 is equal to 2. And last but not least, f of 10. So the t value is 10. So t is not 8, t is 10. So this is the one I'm going to use here as this function. So I'm going to do 14 minus t, which t is 10. And that's going to give me 4. And so f of 10 is equal to 4. So that's the idea of what you're doing with these functions. Whoever is running this at this point, give them a chance to try number 2 here. So pause the video. Okay, now that you've had a chance to try that, let's go through this. So my 0 is my x value that's here. So I come over here. 0 is not less than negative 2, so we're not going to use that one. 0 is between negative 2 and 1. So we're going to talk about this one right here and plugging in for that function. So I am going to do 0 plus 1 quantity squared minus 3. Do your parentheses first, which is 1. 1 squared is 1, minus 3 is negative 2. So we should have gotten a value of negative 2 out of that. F of negative 5. So negative 5 is my t value. So negative 5 is less than negative 2. So we're going to talk about this function here. And it just comes out to an answer of negative 6. There's no t value or x value, sorry, in this case, to fill in. So we just get negative 6 as an answer. F of 7, so we look for where 7 would fit. So 7 is greater than or equal to 1. So we're going to fit here, and we fill it in for x. So x is 7. Our output is then just 7. Essentially what happens there is the output matches with the input. Last but not least, f of 1. So if x is 1, I look for where that would match. Now, x is 1 does not fit right here because it says just less than 1. So x is 1 is going to be here where 1 is greater than or equal to 1. So we fill that in. X value of 1 is going to just give me an output of 1. Okay, hopefully we did okay on those. Okay, example 2 here. So understanding and reading our chart here. So g of 2. So 2 is, again, you can see this g of x is equal to y. So this is an x value that's here of 2. If I go on my x-axis to 2 and find the graph, it's right here. That y value is 2. So f of 2 or g of 2 is equal to 2. G of what is equal to 3. So this is my y value of 3. So I'm going to go on the y-axis to 3, and I actually have 2 different places that this comes out to. So I get negative 5 as an answer, or I get positive 3 as an answer there. And we want to include both of those answers. And then g of -3, so this is an x value of -3. I'm going to come over here to -3, and this can be kind of tricky, but remember if I come down to this point here, it's an open circle, so it's not included. Same thing with the point that's down here, open circle not included. So where the value is for this function is right here, and it's got a y value of 6. So that would be my answer there. Okay, you are going to do a Delta Math assignment with that information. Feel free to use your notes.